Hello and welcome to the Chapter 4 video. This is on comparing data sets. Mostly, all the things we're going to do in this chapter is kind of taking what you know and expanding it a little bit. You've done a lot of different displays of data, histograms and box plots. You've worked with those, even pie charts and all these other things. We're going to introduce the stem and leaf plot today a little bit. I don't think we've worked with that much. And we're also going to introduce the time plot today. And instead of just taking one set of data and describing it using the big three, or some of you are using CUSPS, instead of just one set of data, we're going to have multiple sets of data, maybe two or even more sets of data that you need to compare these big three using comparative language. Okay, that's the big goal. We do have this extra little thing, the seed that we're going to plant in your head about re-expressing data, and we'll get to that in a minute. Okay, so take what you know and expand it a little bit into some new things. Okay, instead of one set of data, now sometimes you have two sets of data or more, and which we're going to see. It's still the big three. When you do a problem for us in class or when you're doing an AP problem, you will get graded on these three things. They will be looking for these three things: center, shape, and spread. We have different choices for these. For the center, you have the mean, the median, the mode. For the shape, you just got to describe it. For spreads, we have IQR, range, standard deviation. We have different tools of these. You got to make a proper choice for what you're looking at. In this case, we have the wind speed and over the summer and over the winter, and the number of days for each particular, like number of days for each particular wind speed kind of thing. So it's just in the summertime or winter wind speeds. Okay, so when you look at this data on the left, you'll see that it's skewed to the higher numbers. So when you have data that's skewed to the higher numbers, one big topic that you need to have in your toolbox is knowing that skewed data affects the mean and it affects the standard deviation, because those calculations come from, when you do the calculation, you use every single data point to make those numbers. So when data is skewed, those really big or really small numbers can really mess up your value for the mean and the standard deviation. So we actually avoid those when you have skewed data. So one thing you should know is if you have skewed data, you should be using the median as a typical value, right? The median is always a good value to use anyway, because it's usually, I mean, by definition, it's in the middle of your data. And that's a typical value, which is what you're trying to do. Say, hey, if I have a typical winter and a typical summer, wind speeds, then how do I compare those, right? Is one bigger than the other? So let's look at medians. Now, sometimes it's easier. It's like given to you. If it's a box plot, you're going to have it right in front of you. You're going to know what your median is. But if it's a histogram like this, or a bar chart, you're going to have to like figure it out on your own. You're going to have to say, okay, there's like 79 here and maybe 57 or 8 here, 20 here, 19, 18, maybe 3 and 2 and 1, something like that, and add them all up, get your total. And then you're going to have to go halfway from the left or right and find out where that median is. And also, it's not going to just be one number when you have a graph like this. It's going to be a whole range. So you might end up saying, oh, my median is between a half and 1, right? Mile per hour kind of thing. And same thing over here. I can probably figure it out. Here would probably be like maybe 1.5, 2, maybe 2 to 2.5. But it's going to be a range of values like 2 to 2.5 miles per hour. And that's going to be my median. Okay, so this is a histogram. These are histograms. Sorry if I said bar chart earlier. Histograms. Okay, so you got to count that up and figure it is. But once you figure out where the medians are, it's just an easy comparison. This median over here for the winter wind speeds is higher or larger than, and see that comparative language, larger than or higher than the summer wind speeds. Okay, so you would just compare the centers using medians. Then you look at the shapes. This is skewed to the higher numbers. This is roughly symmetrical. Don't get too hung up on this little piece here. Don't think that this is skewed as well, because you have this whole chunk here evening out with those, and it's roughly symmetrical. Okay, that's shape. And then the spreads, you could use the range maybe. Look at the range, right? Oops, you got a maximum on this way up at 7, don't we? So you could use the range. You could figure out what the quartiles were, especially if you had a box plot. You could not a yeah, you could box and whisker plot. You could see those quartiles really easily and use the IQR. Same thing over here. You could use the IQR and then compare those IQRs. Oh, this spread is larger than this spread. This has a spread of 7. This only has a spread of 4 for the range, right? And don't just say spread, you say range, right? This has a range of 7, range of 4. This one is larger than the summer months. Okay, so you got to put all that in there. Comparative language, context, and use the numbers, okay, to compare groups. It's not that hard, but people are just like, I don't know, lazy. People are lazy and they try to shorten words, they shorten sentences, and they don't feel like writing that all out on paper, but you have to write it all out. Okay, new type of graph. So we're expanding our repertoire, our toolbox of graphs. This is called the time plot. Why? Well, because the x-axis is time. Could be hours, days, months, whatever, but it's always time. That's why it's called the time plot. And then in this case, this is still that wind speed data. It's just individually put out there. So you can see every single day put out there for the year, 365 days. So it's nice because you can see every day and you can kind of see that pattern. So just look out for time plots. You should know what they are. Okay, this is the same data again, but displayed using categorical data, like kind of grouped into categories of months, right? So now it's in box and whisker plots. This is nice too, because now I can see all these medians for every month, and you could see the maximums and minimums and all that as well. So it really kind of helps to compare different months and things. But you can, these are some new types of graphs that you can use to just get different looks than you're used to looking at before. All right, so you need to get used to describing data using all kinds of graphs and using your big three. Here's another type of graph. This is a stem and leaf plot. Definitely need to get used to this one. You need to be able to write your own. You'll see that in the middle here, this is all lined up, 2, 2, 3, 3, 4, 4, 5, 5. This is the center of your data, or center of the value, and then it's like goes from there. You can see there's a key down here. You have to have a key when you make these. If you don't have a key, you're going to get it wrong, or at least partial wrong. You can see the key here. It says 4 and then 5 on the right. That means 45 years old for US president. And then 4 and 6 on the left. That's 46 years old for the British Prime Minister. So these numbers are British Prime Minister ages, and this is the ages of the US presidents. So how to read this? Well, you got a 24, so a 24-year-old president, US president. If I go here, I have maybe a 56-year-old British Prime Minister. Okay, so that's how you read it. Notice that they keep this nice and even in the middle. If you're going to split it into like the lower 20s and upper 20s, even if you don't have an upper 20 value, you have to put that place marker there to give the relative view of all your data so that the data looks like it's supposed to. Okay, so comparing these two data sets, I would have to maybe count these up and then find out where that median is. I'm not exactly sure, but I'm assuming it's kind of in here somewhere. And you have to find it. It's probably like 53 compared to 51 or something like that. You'd have to count how many, data sets, data values you have and find the middle one for the median. So compare your big three. Compare your centers, compare your medians, compare your shapes. This one, well, actually, they're both fairly symmetrical, and they both kind of have that normal shape to them, roughly. They're not perfectly normal, but they have a normal shape, roughly. And then the spreads, you could use, again, you could use the range. You could figure out what your quartiles are and figure out what the IQR is and use that if you wanted. But you got to compare the big three and say, oh, this one's larger than this, or this one's smaller than this, or whatever. Use your comparative language. Okay, but getting used to stem and leaf plots and then also comparing data. All right, so that's new graphs. And the last thing we just need to talk about is re-expressing data. Like I said, this is just a seed right now in your brain. Um, yes, it's useful when you're looking at single variate data, but it shows up more later when we do bivariate data, when we're trying to take scatter plots and try to make them into a linear pattern. It also shows up later when we're trying to use normal curves on data, which we haven't got started on any of that yet. But for right now, if you have some data, if you look at this, this is the salaries of a bunch of CEOs. If you look closely, it's kind of hard to see, I know, but if you look closely on this box and whisker plot they drew in below this, you're going to see like it has like 20 different outliers or something outrageous. It's just crazy data. Why? Well, because some people, there's like a whole bunch of people who make really high salaries as CEOs, and then there's even more people that just make about the same salary. So you get this skewed to the higher number data, right? It's skewed to the higher numbers. It's really hard to work with this. It's really hard to explain or describe this. So one point we're trying to get across is it's okay to switch units on your data. This is in dollars right now. I think it's in millions of dollars. So if you wanted, you could take those millions of dollars and you could do the log of those data, log of those values, and change the actual units on it. And when you do that, you're going to see this turns into a normal curve shape, right? It's kind of has that nice symmetrical normal bell curve shape. For now, not a big deal. Maybe you might be saying, well, it's kind of weird to be talking about the log of millions of dollars. It's hard for people to, put that in their brain. But later on, it's going to be useful more because this is turned into a normal shaped curve, and we can use all the tools that we're going to learn to analyze that data using normal shapes. Okay, so that comes up later. But just for now, just know it's okay to re-express data. You can change the units on them, and you can do things to them like log or take the square root or square data or just change the units. Change from dollars to pounds or to yen or whatever. All that's allowed as long as you're not changing the truth, right? You're just changing the kind of the look of it a little bit, but you're not changing the truth. The truth is still there. Okay, that's it. So summary, make sure you use the big three, center, shape, and spread, or CUSP-BS, and make sure you're comparing them. You have to use comparative language. Greater than, less than, about the same. And yeah, and make sure, we also talked about your choices, right? So for center, when data is skewed, you don't want to use the mean or the standard deviation. You want to use the median and IQR, and for the center and the spread, right? All right, that's it. See you in class.